Hello there, guys. This is another episode of Maybe I'm Rambling. Now, we're going to talk about the NASA science, the NASA rover has touched down safely on the red planet, otherwise known as Mars. The Perseverance rover's first image from Mars. This is the first image NASA's Perseverance rover sent back after touching down on Mars on February 18th, 2021. The view from Perseverance's hazard camera is partially obscured by a dust cover. The agency's latest and most complex mission to the Red Planet has touched down on Jezero crater. Now it's time to begin testing the health of the rover. The largest, most advanced rover NASA sent to another world touched down on Mars Thursday. After a 203-day journey, traversing 293 million miles, 472 million kilometers. Confirmation of the successful touchdown was announced in Mission Control at NASA's Jet Propulsion Laboratory in Southern California. Packed with groundbreaking technology, the Mars 2020 mission launched July 30th, 2020 from Cape Canaveral Space Force Station, Florida. The Perseverance rover mission makes an ambitious first step in the effort to collect Mars samples and return them to Earth. This landing is one of the most pivotal moments for NASA, the United States, and space exploration globally. When we know that we are on the cusp of discovery and sharpening our pencils, so to speak, to rewrite the textbooks, said acting NASA Administrator Steve Jerzik. The Mars 2020 Perseverance mission embodies our nation's spirit of persevering even in the most challenging of the situations, inspiring and advancing science exploration. The mission itself personifies the human idea of persevering toward the future and will help us prepare for the human exploration of the red planet. About the size of a car, the 2,263-pound 1,026 kilogram robot geologist and astrobiologist will undergo several weeks of testing before it begins its 2-year science investigation on Mars' Jezero crater. While the rover will investigate the rock and sediment of Jezero's ancient lake bed and river delta to characterize the region's geology and planet's climate. A fundamental part of its mission is astrobiology, including the search for signs of ancient microbial life. To that end, the Mars Sample Return Campaign, being planned by NASA and ESA, European Space Agency, will allow scientists on Earth to study samples collected by Perseverance and search for definitive signs of past life using instruments too large and too complex to send to the red planet. Because of today's exciting events, the first pristine samples from carefully documented locations on another planet are another step closer to being returned to Earth, said Thomas Zerbichin, Associate Administrator for Science at NASA. Perseverance is the first step in bringing back rock and regolith from Mars. We don't know what these pristine samples from Mars will tell us, but what they could tell us is monumental, including that life might have once existed beyond Earth. Some 28 miles, 45 kilometers wide, Jezero crater sits on the western edge of Isidis Planitia, a giant impact basin just north of the Martian equator. Scientists have determined that 3.5 billion years ago the crater had its own river delta and was filled with water. The power system that provides electricity and heat for Perseverance through its exploration of the Jezero crater is a multi-mission radioisotopic thermoelectric generator, or MRTG. The U.S. Department of Energy, though, provided it to NASA through an ongoing partnership to develop power systems for civil space applications. Equipped with 7 primary science instruments, the most cameras ever sent to Mars, with its exquisitely complex sample cache system. The first of its kind sent to space, Perseverance will scour the Jezero region for fossilized remains of ancient microscopic Martian life, taking samples along the way. Perseverance is the most sophisticated robot geologist ever made, but verified that microscopic life once existed carries it no one's burden of proof, said Laurie Gates, director of NASA's Planetary Science Division. While we learn a lot, with the great instruments we have aboard the rover, it may very well require the far more capable laboratories and instruments back here, on Earth, to tell us whether our samples carry evidence that Mars once harbored life. Landing on Mars is always an incredibly difficult task, and we are proud to continue building on our past success, said GPL Director Michael Watkins. But with Perseverance advances that success, this rover is also blazing its own path and daring new challenges in its surface mission. We built the rover not just to land, but to find and collect the best scientific samples for return to Earth. It is an incredibly complex sampling system and autonomy not only to enable that mission. They set the stage for future robots and crewed missions. The Mars Entry Descent and Landing Instrument Sensor Suite collected data about Mars' atmosphere during entry, and the Terrain Relative Navigation System autonomously guided a spacecraft during final descent. The data from both are expected to help future human missions land. In other words, more safely and with larger payloads. On the surface of Mars, Perseverance-sized instruments will have opportunities to scientifically shine. Mastcam Z is a pair of zoomable science cameras on Perseverance's remote sensing mast, or head, that creates high-resolution, color 3D panoramas of the Martian landscape, also located on the mast. The supercam uses a pulsed laser to study the chemistry of rocks and sediment. It has its own microphone to help scientists better understand the property of the rocks, including the hardness. Oh, jeez. Located on the turret and end of the rover's robotic arm, the planetary instrument for X-ray lithochemistry, Pixel, and the scanning habitable environments with Raman and luminescence for organics and chemicals instruments, Sherlock, will work together to collect data on Mars geology close-up. Pixel will use the X-ray beam and a suite of sensors to delve into a rock's elemental chemistry. Sherlock's ultraviolet laser and spectrometer, along with a wide-angle topographic sensor for operations and engineering, Watson Imager, will study rock surfaces, mapping out the presence of certain minerals and organic molecules, which are the carbon-based building blocks of life on Earth. The robot chassis is home to 3 science instruments as well. Radar Imager for Mars Subsurface Experiment RIMFAX is the first ground-penetrating radar on the surface of Mars and will be used to determine how different layers of the Martian surface formed over time. This data can help pave the way for future sensors to hunt for subsurface water ice deposits. Also with the eye on the future red planet explorations, the Mars Oxygen and In Situ Resource Utilization Experiment (MOXIE) technology demonstration will attempt to manufacture oxygen out of thin air. Yeah, that's a bit of a pun right there. The red planet's tenuous and mostly carbon dioxide atmosphere. The rover's Mars Environmental Dynamics Analyzer (MIDA) instrument, which has sensors on the mast and chassis, will provide key information about present-day Mars weather, climate, and dust. Currently attached to the bill of Perseverance, a diminutive Ingenuity Mars helicopter is a technology demonstration that attempt the first power-controlled flight on another planet. Project engineers and scientists will now put Perseverance through its paces, testing every instrument, subsystem, and subroutine over the next month or 2. Only then will they deploy the helicopter to the surface of the flight test phase. If successful, the Ingenuity could add an aerial dimension to exploration of the red planet, in which such helicopters serve as scouts or make deliveries for future astronauts away from their base. Once Ingenuity's test flights are complete, the rover's search for evidence of ancient microbial life will begin in earnest. Perseverance is more than a rover, and more than an amazing collection of men and women that built it. It got us here, said John McNamee, a project manager of the Mars 2020 Perseverance rover mission at GPL. It's even more than the 10.9 million people who signed up to be part of our mission. This mission is about what humans can achieve when they preserve. We made it this far, now watch us go. A primary objective of Perseverance's mission on Mars is astrobiology research, including the search for signs of extracorporeal life. The rover will characterize the planet's geology and planet's climate and be the first mission to collect and cache Martian rock and regolith, paving the way for human exploration of the red planet. Subsequent NASA missions in cooperation with ESA will send spacecraft to Mars and collect these cache samples from the surface and return them to Earth for in-depth analysis. The Mars 2020 Perseverance mission is part of NASA's Moon to Mars approach, which includes the Artemis mission to Moon that help prepare for human exploration of the red planet. JPL Division of Caltech in Pasadena, California manages the Mars 2020 Perseverance mission and Ingenuity Mars helicopter technology demonstration for NASA. For more put the Perseverance, you can get these links. Now let me know what you think honestly in the comments section. I personally think that some of this technology should be better suited toward fixing the infrastructure on this planet stuff, trying to run away to another one. But hey, that's just me. I was like, yeah, but I can't fix no house. But whatever. Maybe next time on, maybe I'm rambling.